Why is building AI vision software so expensive? Hi, I'm Sergio. In the last 7 years, I built dozens of computer vision projects, from software for companies to research projects for universities, innovative prototypes in different niches, and I helped hundreds of students through video courses or one-on-one consultation achieve their success with the project. And I have to absolutely address this question right now because I get a lot of requests, too many requests on LinkedIn or on my website about building computer vision software for some companies where the budgets are a few $1,000s or sometimes even hundreds of dollars. And if you are a bit into the field, you know how unfeasible this is. So in this video, we're talking about software that you can build if you're a developer, like a solo developer or a very small team can build. So we're talking about software for on a small scale for small companies. We're not talking about enterprise software like ChatGPT or very big solutions like that. And this video is going to be unconventional in its way because I'm going to ask you a lot of questions to make you reflect on what you want from this software and what complexity are you expecting from this software. So if you're a developer, you know what questions, what you need to go through when thinking about building a solution. And these are the questions that I ask always my clients to when I want to dive deeper into the problem that they're facing and what they want to achieve. And if you are a client, based on this question, you can understand yourself the complexity. The idea is that these are yes and no questions. The more yeses you will give to all these questions, the higher you can expect the price. And I'm going to give you many examples based on my experience on each of them so that you can relate with some real world scenario project. Let's start right away. Here we start with the question. So we have an AI vision software. It could be any software you can think of. Let's always think about a small software that you can build in a relatively short time, where short time it can be 2 to 8, 10 months. This type of software could be traffic management systems, visual inspection, and many other things like this. Let's now start with the first question. Does it need to run for continuously long term? When you need to build a solution, there is a huge gap from a solution, a prototype that needs to run for a very short time, like it could be a day or 2 days, on a solution that needs to be running 24/7 for 1 year or more year. When you need to build a solution that needs to run for a very short time, you can put them that without a very proper defined structure. It can be like a Python code that could run on a machine that you can run and you can check while it's running the very short amount of time. When you need something that needs to run long term, then it's a complete different story. You need to have a proper structure. You need to take into account all the possible things that can happen, like system updates, like if the OS system will be updated, will the software still run? What if there is shortages of electricity and then you run again the machine? Does it run away? Are there any problems that can happen? Is the software connected to a camera? What if the camera gets disconnected? Will the software understand that the camera is not connected? Will provide some error to understand this? So there are things that if it's a small solution that runs for a day, you don't need to develop because it will take a lot of time. You can check that while it's happening, so you don't need to have a very complex structure. But when the software is it's more complex, needs to run for a long time, you need to take into account all these things. You need to consider maintenance, debug, and there is a huge gap again in all these factors. So if the software needs to run long term, you can expect a huge increase already in the cost of the software. And at the end of this video, we can also give some numbers, of course, very general number, to understand what you can expect, what's the difference from a cheap solution to a more complex solution. Second, is reliability a major factor? When you build a software, you often and usually you need to give some certainty that the software will replace some manual effort and that will have some reliability. If you are tracking if you build a software to inspect defects on a system, let's say that on an automotive industry, the software there is there to understand when there is defects on some part of the cars, and if there is a defect, the software needs to raise an alert so that they can pause the production, they can fix the defect that is happening there, and so on. In this case, you need a lot of reliability. To achieve the reliability, you need to take into account a lot of factors. You need to take into account having a very big data set, usually tens of thousands of images. So the more you need reliability, the more you need to take images. If there is a bigger scale, if there are many parts of the cars, if there is not control light environment, then you need even more data to guarantee the reliability. In addition to this, the reliability needs to be continuously guaranteed, so you need to schedule maintenance and updates, like monthly updates, monthly tests, to make sure that the data is close to 100% accuracy, and so on. This is a very big factor in the price when you build a solution. Does it need to upgrade and scale easily? And we can connect to the previous step. When you want to guarantee reliability, there needs to be maintenance and updates. And in this case, you need to make the process very simple for the software to be updated. Otherwise, the cost of the development for the updates will be very high if there is not a proper structure for the updates. So you need to build systems that can guarantee the update with a very efficient process for the specific software that you have. This factor will count a lot in the price of the software. Does it work on a control environment? If it needs to work on a control environment, it's much easier than working on an environment that is not controlled in lighting, in weather condition. I will give you an example of something I recently worked on. When you build a software to identify the traffic, vehicle traffic, there are so many factors that will play a huge role in the complexity of this software. The position of the cameras, the resolution of the camera, different cameras might have different lighting, different color, different way they process the frames, different frame rates. So each camera is different. So this is a big factor. The position of the camera. Each camera is, if you have many cameras, each camera is positioned differently. Then there is again another factor. This accounts problem in many ways. On the data set, so you need, the more variety you have, the more data you need. So different cameras, different weather conditions, then all the vehicles so you need also data sets for all the possible thousands of type of vehicles that go there, needs to be all taken into account. In addition to the dataset complexity, there is the complexity of the software structure, because when you're going to track vehicles from different cameras and different frames per second of each single camera, then in that case, the software needs to have different parameters and need to adapt to the different camera settings. This is another very big complexity when you take into account on a larger scale project. Are there any specific complexities to consider? As I said, for this example of the cameras, there are complexities if there are some very complex position of the camera where the vehicles are not well visible, and they need to have some extra attention to detect the objects, or if the objects are very small. That these are all very big complexities. If you take into account other projects like I had in the past to identify defects of some products, there is a big difference if the product of the defect is very well recognizable. Let's say if you have glasses and there is a huge scratch or it's a broken glass, that's an easy defect to recognize. If there is a very small scratch or there is some shade of the color of some part of the glasses, that's a very complex defect to recognize. It will take into account adding a huge amount of data to process, having some fixed light environment, so there needs to be also attention and work on the type of camera, the type of lighting that needs to go there, and so on. Who is the user? Who is the user of your product? Is there a technical team that can understand the code, that can fix small bugs, that can run the code? Or, like often it happens, is a non-technical person that wants to have the easiest solution possible, that just wants to run? There is a huge difference from having a code that a technical person can run and a standalone solution that can run on any machine with a graphic user interface. So in addition to developing the solution, ideally another developer needs to develop a user-friendly graphic interface. All of this needs to take into account the system where the software will run. If it needs to run on Windows, you need to create a certain type of installer. If it's on Linux, another one, on Mac, another one. So when it's the code, you can run pretty much on any machine, Windows, Linux, Mac, they will run the code without any problem. When you need to create the solution for a non-technical person, there is much bigger complexity to make that simple for them and make them simple to install. Is it an innovative solution? If it's an innovative solution, there is a big risk factor that you're going to take. When it's an innovative solution, you are guaranteeing the delivery of something that was never done before. And even though you have some process, you think you can deliver that, you are confident you can deliver that, there are a lot of things that you can't know yet, a lot of factors that will take you a lot of time. I built this for experience because I built so many innovative solutions for the clients, things that were never there, and there is always a big problem in the estimation time. If you think that it takes 20 hours to build that, it might take even 100 hours, and unfortunately you can't know that exactly. So you need to overestimate as much as possible, consider the innovative factor, this, and the client should understand that if they're paying for something that was never delivered, they need to pay much more because you're guaranteeing and taking this very big risk. Of course, I always recommend to take risks that you know you can afford to take. So go a bit above your experience, what you can make, because it will push you further to make solutions that you have never done before. Don't go too far because the risk of failing might be too high if you don't have experience with that. You can know this based on your experience on what you can achieve. Is efficiency a requirement? When you need to build a solution that needs to run for one single camera on a single machine that can be any machine, it's one thing. When you have certain constraints, for example, the solution cannot run on a desktop machine because it needs to be on a manufacturing or some company where they have like certain requirements, they for space, for electricity and so on. In that case, you might need to make your software more efficient to run on small boards like NVIDIA Jetsons, or other small boards like that. Or if it's a solution that needs to run on a very big amount of data, like if you want to run the solution on multiple cameras, let's say a software counting solution on multiple cameras, 20 or plus cameras, like I had this request in the past, you can't just take a basic software and place that on the machine because it would be so inefficient that the cost of the hardware would be very, very high. So if you put a cheap software without paying attention to the efficiency, you will pay so much in the server cost that it doesn't make any sense. So you need to make the solution very efficient so that the 20 plus cameras can run on the most small efficient server and the cost of the server will be to the minimum. So you will save in server costs, but you have to pay much more for the expertise and for building an efficient solution. Is speed in development a factor? Do you need this solution built in 1 month, 2 months, or you can wait for the time, you can wait 1 year? So in this case also, when you want something faster, usually for a premium service to have like all the attention from the developer team, you will pay an extra fee. So on what scale the software will be used? We already talked about these aspects now in the video. Do you need this to work only on one camera, two cameras, on 20 cameras at the same time? Does it need to work on a single computer, on a single location? Does it need to work on different locations? Do you need to rent or buy specific hardware to run and test the solution? And I do this a lot. So when some clients came in the past, they needed a specific solution to work on a specific device or with a specific camera, I would buy that camera or that device. And the cost of the device are never cheap. And when you buy some cameras, they are never very cheap. And this needs to be taken into account, because when you are going to deliver something, you need to test it on that specific device. So if you are going to build a software that runs on an NVIDIA Jetson board, you can't just build a software and send it and say, okay, try it on the board. You have to buy the board, you have to run it on the board and test it on the board to make something very efficient and to make sure that it runs. Otherwise, you're just guessing, you're not offering a good service. Let's now talk about numbers, and imagine this is what you were interested for since you entered in this. I will be generic because we don't have any specific computer vision solution we're talking about, but let's understand the difference from a cheap solution to a more complex solution, taking into account the costs of a developer to build this. I found a range online for AI computer vision developer, which goes from $50 per hour, the minimum for the least experience and also in the lower cost living countries, to around $200 per hour for a more experienced. And let's take this cost, this is the hourly cost, and let's put it into the perspective of building a software. A cheap solution is a solution that doesn't take into account everything that we discussed today. So all these questions right here, it's a solution that needs to run for a specific time, there is no reliability needed, it's not a major factor, doesn't need to scale or upgrade, it doesn't need to, it works on a controlled environment, there are no complexity and so on, the user is a technical user, so everything that the easiest possible, so that could be an easy solution, could be built in 10 days, 15 days, up to 1 month. So you can expect, if you hire a developer, to spend a few $1,000s to have a cheap solution which doesn't take into account all these aspects. When we talk about a more complex solution that takes into account all the things we discussed in this video, we are talking about a development process that goes from 2 months to 8+ months, and it could cost $50,000 plus dollar, considering a very small team. In this case, I'm talking about solution that a solo developer could build, or a team of 2-3 people. That's how we build a solution in 2-3 people, like someone developing the computer vision part, someone for the annotation, someone for the user experience. And these are the costs that you can imagine. And of course, these we're talking about small scale. If you are thinking about enterprise, more complex solution, then you need to multiply this by 10, hundreds, or plus. I hope this video was useful for you. Let me know what other questions you have about this. What is your experience with the cost of AI vision software? This is all for this video. See you in the next one.